I'm Anil Kumar, sharing with you questions from the test paper, and this time we'll discuss question number 1, which is right there, which says determine the x, y, and z intercepts of the plane with the vector equation r equals to minus 1, 2, 3 plus s times minus 2, 2, 3 plus t times minus 3, 2, 6, where s and t belongs to real numbers. Now there are many different methods to solve this. I'll discuss with you one of the most efficient way of answering this particular question. Now you will find that Cartesian form of the plane is probably the best to find xyz intercepts, and therefore our strategy is to write the equation in Cartesian form. Right? So to write the equation in Cartesian form, we can find the normal, which should be cross product of these two directions. Right? So the normal vector for us will be minus 2, 2, 3 cross product with minus 3, 2, 6. Right? Then we get the normal. We can use the given point and find the equation in Cartesian form. And from there, we'll find x, y, z intercepts. So there are different ways of doing the cross product. I prefer to use the matrix, so we'll follow the matrix, which is I, j, k. These are the unit vectors along x, y, z. Then first vector is minus 2, 2, 3. The other one is minus 3, 2, 6. Right? So we could write this as I times 2 times 6, 12, minus 6, minus j, minus 2 times minus 6 is minus 12, minus 9, but the negative sign makes it positive, plus k. For k it is minus 2 times 2 is minus 4, minus 6, which is positive, right? So that is how. Let me simplify here itself and write down the answer. 12 minus 6 is 6. We'll write 6i, and minus 3 minus minus makes it plus 3j. Okay, and here we have plus 2k, so plus 2k. So the normal vector for us, we could write this normal vector as equal to 6, 3, 2, right? So that is the normal vector. Since we know the normal vector, the Cartesian equation of the plane could now be written as equal to the ax, so which is 6, right? 6x plus by, so 3y, plus cz, which is 2z, plus c, right? So that is what it is. So Cartesian equations will be, we can say this is equal to 0. To find the value of c, we'll substitute the given point. We know the point on this plane is minus 1, 2, 3, right? So if I substitute this point here, I get 6 minus 1 plus 3 times 2 plus 2 times 3 plus c equals to 0, minus 6 plus 6 plus 6 plus c equals to 0, and that is c is equals to minus 6, right? So we get 6, and so that gives 6 equals to minus 6, and therefore the plane equation could be written as 6x plus 3y plus 2z minus 6 equals to 0. So that is the equation of the plane in Cartesian form, right? Now we are going to use this particular equation to find x, y, and z intercepts, right? So I'll write down this equation here now. We say the equation is 6x plus 3y plus 2z, and we'll write this as equal to 6, right? Now from here we'll find x, y, and z intercepts. So x intercept. So at x intercept, we know y and z are 0, right? So we will put y and z as 0. So once we put that, we get 6x equals to minus 6, or x is equals to minus 1, correct? So x intercept for us will be minus 1, 0, 0. As far as the y intercept is concerned, we'll do the same thing. We'll put 0, 0 for x and z. So y intercept will be at y equals to 6 divided by 3, which is 2. And therefore, we could write this point as 0, 2, and 0. And to find z intercept, We'll put x and y as 0. So z will be equals to 6 divided by 2. So z equals to 3. And the point will be 0, 0, 3. So x, y, and z intercepts are these, right? So we can write down our answer. And the points are minus 1, 0, 0, 0, 2, 0, and 0, 0, 3, right? So this is probably a very efficient way of finding x, y, and z intercepts when you're given equation in vector form. I hope you appreciate it. Thank you and all the best.